Hey guys, this is Einar. Welcome to your 18th tutorial in basic statistics in Excel. Today we're going to talk about percentiles, and I'm really excited about this because the percentile is one of my absolute favorite statistical measures. The reason for this is that it can be used for so many things. It can be used as a centrality measure, but it can also be used as a measure of variation. And the reason for this is that it's used to travel through data. It's much like the median in the way that if you said you were looking for the 50th percentile, you would actually be looking for the median because the 50th percentile is the centermost observation in the material. And in fact, the equation for the median, just look at the tutorial if you're curious about that, is actually n divided by 2, which is the centermost observation. So what we're doing in this part of the equation is we're translating it from a list of observations with an n as a total to a list of percents with 100% as a total. And it's well worth noting also that, you know, theoretically we're moving from an idea of, you know, observations which are discretely separated from one another to a list of percents that is continuous. So we're not really just talking about observations. Our percentiles will be theoretically located in between observations sometimes. So this is going to have some implications for the way we're going to calculate this now, but I'll talk about that when we get there. So we're just going to get right to it, and first we need P. So we're just going to choose the percentile that we're looking for. I'm choosing the 39th percentile. So this is the percentile we're looking for. We're also going to need an n to multiply our percentile with, and we can find that by summing up all our frequencies. So we go sum, and we sum up all the frequencies in our frequency table. And we get 25. Excellent. Now we want x0, which is the lower class limit for the class where the percentile is located. Now how do we find which class the percentile is located in? It's kind of hard when you're just working with frequencies. It would be much easier if we actually had some percents to see. So in order to do that, we're going to calculate first our cumulative frequencies. And if you're unsure about what I'm doing now, look at the earlier tutorials because we've gone through this before. This though will be new. We're trying to find the shares of the cumulative frequencies. So what we do is we take the cumulative frequency and we divide it by our total. And we fix this with a $sign right there. So it doesn't change. We move it right down there and we get 1. So the first 8 cumulative frequencies are 0.32 parts of the material. That's their share. And when we reach the last class here, we have 1, which is you know, 100%. And to be extra clear about this, we're going to multiply them by 100. So we actually get percents here. So I pull it down and we get 100% there. In the first class, we have 32% of the observations. In the first 2 classes here, we have 60%, etc. And we end at 100. So we've done it correctly. Now we can see that, okay, we're looking for the 39th percentile. We check here. The first class, I have 32%, so it's not there. The second class is up to 60%, so it must be located somewhere in here. We found the percentile class. Now the lower class limit for this is going to be 15.5. The reason for this we've gone through in earlier tutorials. N0 is going to be the number of observations up to the lower percentile class limit. So we're going to look at our table again, and we see we have 8 frequencies, and then we have 15 frequencies, but that's including this class, so we're just looking for the 8 right now. So we're just going to write 8. N1 is the number of observations to the upper percentile class limit. Well, that's 8, and then we go up here to the upper class limit, which is 21.5, and we have 15 frequencies there, so we're going to write is equal to 15. The class width, this is where it's going to be slightly complicated for you guys now, because the class width is actually 21.5 minus 15.5. And that's equal to 6, which might be confusing to you, because before when we used this table, we said we had a class breadth of 5. And that was just kind of to keep it simple for you guys, but the reason is that we don't have observations that are placed at 15.5 in a data set. You see, you have no ages with decimal points here, so there's a reason that we've done it this way. But when it comes to calculating our measures, we actually use these decimal points anyway. It's gonna have slight theoretical implications, and the main reason that we're doing it now is because, well, we translated from a list of discrete observation to a list of percents that actually are sometimes located in between ages. So we need the decimal point thinking, so to speak. So we're including that now. If we look back at our formula, we can see we now have all the parts that we need. So let's just calculate the percentile before we move on. So we're going to write equal to, and take a quick look at our formula. Oops, I'm sorry about that. And take a quick look at our formula again. We need x0, okay, x0 plus, take a look at the formula again, Pn divided by 100. We need two parentheses, and we go P multiplied by N divided by 100. We close that parenthesis. Minus N0. So we go there and we see N0. And actually, I think we need another parenthesis here. There we go. And we're going to divide this by another parenthesis. N1 minus N0. So let's do that. N1 minus N0. Close the parentheses. We close the parentheses again, and then we multiply this by our class width. Okay, so this is the formula we're looking for. This is actually the Excel version of this formula. So let's get right into it and calculate our percentile. We get a percentile of 17. So the 39th percentile, when we move 39% into our data material, like this, we end up at 17, which is located in this class. So I think we've done it correctly. But there's a way of checking if we've done it correctly, actually. So we go and we write is equal to percentile. And we choose an array of numbers, and this is the reason we have this raw data here, because you need raw data when you're using this function. We select our entire data set, like so. See there, I've selected the entire data set. I need a comma, and K, you might not see it, but it says K there, is the percentile in the form of a number that we're looking for. So let's select this percentile, which is a 39th percentile. Close the parentheses, I hit enter. Oops. What did I do wrong? Oh my god. Oh yeah, of course. In this formula, the percentiles are actually shown as, they have to vary between 0 and 1. So they're moving in shares. They're taken from this scale. So we have to write 0.39 if we're looking for the 39th percentile. Then we get 17.36. Now notice, as before, there's a difference here. Why is there a difference? Well, the difference is because when we're using a frequency table, which we've done in our manual formula, the one here, we're losing detail because we don't know if these 8 frequencies are 10 or if they're 12 or if they're 15. In fact, they're all given the value of the class center. So we're losing detail when we're using frequency tables. So this command percentile is more true than the one we're taking from the frequency tables. But as before, we sometimes don't have the raw data. So sometimes we're going to just have to live with the fact that we have to work with frequency tables. And that's the reason we're learning this stuff. I hope you found this measure interesting. We're probably going to talk about it again, and I hope you can just experiment with this and change the values of the frequency table and see how the percentile changes. And in other words, just have a nice day, and I wish you good luck, and see you in tutorial 19. Bye!